All right, today we've got an awesome comeback story from the world of AI. Imagine a veteran champion, one that everyone thought was past their prime, getting a modern-day training montage and stepping back into the ring to take on the new undefeated king. Well, that's pretty much what happened here. Let's dive in.
So what if the newest, hottest champion in AI wasn't actually new? What if you could take an old piece of tech, give it a modern tune-up, and have it beat the latest and greatest? That's exactly the question researchers at Meta's AI lab, FAIR, decided to ask. So let's meet our two contenders. In one corner, you've got the veteran champion, Convolutional Neural Networks, or ConvNets for short. For like a whole decade, these guys were everything in computer vision, powering photo tagging, medical imaging, you name it. And in the other corner, the new challenger, the Vision Transformer, or ViT. This thing burst onto the scene in the 2020s and just took over.
And this is where our story really begins. The paper calls this the Roaring '20s for computer vision. Suddenly, these transformers, which were actually borrowed from the world of language AI, started crushing ConvNets on all the benchmarks. It wasn't even close. The entire field just shifted, and the old champ was pretty much left in the dust.
You know, it's worth asking why ConvNets were the kings for so long. They had this secret weapon called inductive bias. Now that sounds complicated, but just think of it as a built-in cheat sheet for looking at images. Their whole design was based on this idea of a sliding window that scans across an image, which is a super efficient way to find stuff, like a cat or a car, no matter where it is.
And yeah, the paper puts it perfectly. Their dominance was no accident. They were just really, really good at what they did. But when transformers came along with their crazy high scores, everyone just kind of assumed it was because of their special sauce, this mechanism called self-attention. The thinking was, well, I guess this new thing is just better.
But this is where things get interesting. The researchers at FAIR took a step back and asked a really smart question. They said, hold on a second, is it really this self-attention thing that's so magical? Or have transformers just been getting all the benefits of the latest training methods and modern design tricks that we never went back and gave to the old ConvNets?
So, they came up with this brilliant experiment. It's kind of like taking a classic muscle car from the 70s, say a ResNet 50, and deciding to upgrade it piece by piece with modern Formula One technology. But here's the key rule. They weren't allowed to swap out the engine. The core convolution engine had to stay. They were only going to change everything around it.
Okay, so step one was all about the big architectural stuff. First, they tweaked the overall layout, changing how much work the network does at each stage to make it look a lot more like a modern Swin transformer. Then, right at the beginning, they swapped out the old, complex intake with a simple patchify layer. This just means it chops the image up into little squares, which is exactly how a transformer starts.
And check this out. Just by using a modern training plan, the old ResNet already jumped from about 76% to 78.8% accuracy. Then, after those first big design changes, it creeps up a little more to 79.5%. I mean, it's a nice little boost, but we're just getting warmed up.
All right, next up, they started getting into the nitty-gritty. They brought in an idea called depth-wise convolution, which is really just a more efficient way for the network to process an image's shapes and colors separately. And then they borrowed this really cool trick called the inverted bottleneck. You can think of it like the network taking a deep breath. It temporarily expands its processing capacity to learn richer details before getting slim again.
And whoa, look at that. This is where we see a real jump. The accuracy shoots up from 79.5% to 80.6%. This was the moment they knew, okay, we are definitely onto something here. This old dog has some serious fight left in it. Okay, so one thing transformers are famous for is their huge receptive field. Basically, they can look at a big chunk of the image all at once. ConvNets, traditionally, use tiny little 3x3 windows. So, to copy that big picture view, the researchers did something pretty radical for a ConvNet. They jacked up the kernel size all the way to 7x7.
Now, you'll see the accuracy number didn't really move here. It stayed right at 80.6%. But don't be fooled, this was a super important step. By making the ConvNet see the world through a wider lens, just like a transformer, they were setting the stage for the final game-changing upgrades.
Okay, so let's recap. The overall blueprint is now modern. The engine block has been redesigned. Now it's time for the final details, the little micro adjustments that are going to polish this thing into a real contender. And this is where it gets its new name, ConvNeXt.
So they went in and did a bunch of tiny but critical swaps. They changed the activation function from the classic ReLU to a smoother one called GELU. They used fewer of them.
They swapped out an old normalization method for a new one called LayerNorm. Just a whole list of little things, each one pulled straight from the modern transformer design manual.
And this is just incredible. Look at the result of all those little tweaks. Together, they rocket the accuracy from 80.6% all the way to 82.0%. And here's the punchline. The swine transformer they were trying to copy, its baseline was 81.3%. The upgraded ConvNet didn't just catch up, it surpassed it. The old dog had officially beaten the new kid on the block.
And when you put the blueprints side by side, it's just so cool to see. You have the original ResNet block, then the super complicated Swin transformer block with all its moving parts, and then you have ConvNeXt. It's almost as simple and clean as the original, but it's hiding all that modern power inside. It's just elegant.
Okay, but beating the baseline is one thing. The real superpower of transformers is that they just keep getting better the bigger you make them and the more data you throw at them. So the big question was, could this new ConvNeXt scale in the same way? The researchers didn't stop with one model, they built a whole family of them to find out.
And the answer was a resounding yes. Here it is, the headline number you've been waiting for. The biggest ConvNeXt model after being trained on a massive dataset hit a stunning 87.8% top 1 accuracy on ImageNet. I mean, that's not just good. That is absolutely state-of-the-art.
And this table really lays it all out. When you compare models of a similar size, the ConvNeXt are right there with the Swin transformers and often even a little bit better on accuracy. But here's a kicker. Because they're fundamentally simpler, they were often faster. So you're getting state-of-the-art performance, and sometimes you're getting it quicker. And get this, it wasn't a one-trick pony. They threw harder problems at it, like object detection, drawing boxes around things in a picture, and semantic segmentation, which is labeling every single pixel. And guess what? The modernized ConvNet came out on top there too. This thing was a true all-rounder.
Okay, so this is a really cool story. But what does it all mean? What's the bigger lesson here, beyond just a bunch of numbers on a leaderboard?
Well, there are a few huge takeaways. First, design matters. The overall engineering, the training process, the architecture, all the little details can be way more important than one single magic component. Second, don't count the old-timers out. Sometimes the biggest breakthroughs come from taking something we thought we understood and just looking at it with fresh eyes. And finally, simplicity is a superpower. The fact that ConvNets are so elegant is a massive advantage for speed and efficiency.
And really, this whole thing just leaves you thinking, doesn't it? For a couple of years, pretty much everyone agreed that transformers were just better. It was a done deal. And this one paper completely flipped that on its head. So it makes you wonder, what else are we all sure about in tech right now that's just waiting for someone to challenge the assumption and try something new?